So if you look what we've got in front of us, we've got one cube, 2 cubes, and another 3 cubes, making up 3 steps. The question is asking us how many cubes would we need to make 9 steps. Okay, so what I've done here, I've gone up in stages. I'm looking at, there's 1 cube, there's 2 cubes, and there's 3 cubes. So every stage, you're going up 1 cube. So I've started off by starting with 1 here, then 2, then 3, then 4 and 5 and so on, and keep adding them together, and you should be left with 45. Okay, if we read this question, what I've done so far, I've highlighted the key information in blue, and then in red is the actual question. So if you look at what it says, a farmer has 336 kilograms of potatoes for sale. He sells them in 5 kilogram bags and 2 kilogram bags. He uses the same number of 5 kilogram bags as 2 kilogram bags. How many bags does he need altogether? Right. So, if we have a 5 kilogram bag and a 2 kilogram bag, they obviously add together to give us 7 kilograms. Okay. Now it says there are the same number of 5 kilogram bags as 2 kilogram bags. So what I've done is our total number of potatoes in kilograms is 336. So I've divided 336 by 7. And that gives me 48 bags. So if I have 48 bags, that means 48 2 kilogram bags and 48 5 kilogram bags. There is my extra line of workings there where it showed 48 times 2 and plus 48 times 5 is 336. So that gives me a total of 96 bags. Okay, again I've highlighted the key information here. There's three things that stand out for me: enlargement, scale factor 2, and a center 0. So we know we've got to enlarge the shape, and we've got to make it twice as big as it says the scale factor is 2, and the center is where it's going to start from. So if we look at our center here, center 0, that is where we enlarge our shape from. So the black shape there is the shape that was given to you. I counted away that there was 2 squares away from the center 0 to my first point of that shape. As I want to make that twice as big, because the scale factor is twice as big, I'm going to now double that distance, so it's not 2, it's 4 squares away. So that point I was going to start 4 squares away. Then this is a straightforward part where every length of that shape is going to be doubled. So my first shape down here is 4 squares. My second shape, my enlarged shape, is now going to be 8 squares down. My first shape was 2 squares across. My second shape now is going to be 4 squares across. And so on and so on. Okay, looking at this question, we have 2 pieces of important information. Reflect the triangle in the line x equals 2. So the first thing I've done is draw the line x equals 2. That is a straight line going through 2 on the x-axis. I'm going to reflect that shape in that line. I'm 2 squares away here, so I'm going to be 2 squares away there. This here, my shape, is a direct mirror image of this. Looking at this question, rotate 90 degrees anti-clockwise about the origin. Okay, so we're going to rotate this shape 90 degrees anti-clockwise about the origin. The origin, okay, is our point here, 0, 0. This is our original shape. What we'd want to do is trace this shape on tracing paper and have a point, maybe a pencil, on this point and rotate it 90 degrees anti-clockwise. So follow this arrow and your new shape here will be in this quadrant. Okay, exactly the same shape, just being rotated. Right, The above diagram shows 3 points x, k and y which lie in a straight line. Straight away from that, as it says straight line, I have drawn in here 180 degrees. Okay, so 180 degrees on a straight line, I've drawn that in. It's asking me to find the bearing of x from k. From k, that is where we start. So following our 3 rules for bearings, we go clockwise from north, and our bearing has to have 3 digits. If we've gone 55 degrees already to get to y, we're going another 180 degrees to get to x. So our answer is 55 degrees plus 180 degrees gives me a bearing of 235. Straight away, I'm going to point out this here. 5 miles is equivalent to 8 kilometres. I have used this to help me answer this question. Okay. This conversion table is between miles and kilometres. As I stated below, we have 5 miles is equal to 8 kilometres. If you just simply look at the bottom conversion, 100 to 160, okay, it's quite easy to spot that this here, our kilometres, is 1.6 times bigger than our miles. Okay, you can do that by doing 160 divided by 100, which gives you 1.6. So if you want to convert 15 miles into kilometres, we times 15 by 1.6, which gives us 24. If we want to go back from kilometres to miles, we do 120 divided by 1.6, which gives us an answer of 75 miles. Right, again, I've highlighted the question, the key parts of this question. It says, Kevin's car manually states that the fuel consumption for his car is 20 kilometres per litre. Kevin's car gives distance travelled in miles. What is the fuel consumption of Kevin's car in miles? So that's converting 20 kilometres into miles. You could follow the same method as before, do 20 divided by 1.6, okay, which would give you an answer of 12.5 miles per hour. However, there are other methods of doing it. If you want to convert, look at a similar question here, 120, how do you get 120 to 75? Again, you divide by 1.6. But if we break that down, there are 6 20s in there, so we find out how many 6s are in here. So, here's my answer. 20 divided by 1.6 gives me 12.5 miles per litre. Right, Kevin usually insures his car with annual insurance. The normal cost of insuring his car is a single payment of £210. In a special offer, Kevin is offered 1/6 off his car insurance if he pays 1 month early. The question is, how much would Kevin save by paying 1 month early? So, he pays a single payment of £210, but in this special offer, it says he can get 1/6 off his car insurance if he pays 1 month early. So, by paying a month early, we do £210 divided by 6, which gives us £35. So, how much would Kevin save by paying 1 month early? £35. Right, part 2. Lilliput Insurance offers Kevin identical car insurance for an initial payment of £20, followed by 10 monthly payments of £17.50. Would you advise Kevin to change insurance companies? You must give reasons for your advice. So, in blue here I've got initial payment of £20 followed by 10 monthly payments. Okay, that is important information. You actually need to calculate this before answering the question. It's asking me then, would you advise him to change insurance company or stay with the one he's currently with? So, Lilliput Insurance, if you're starting, if it's initial payment of £20, and then for every 10 months after is £17.50, we have £20 plus 10 lots of £17.50, which give me a total of £195. Now, the annual insurance, which was part 1 of this question, would have been £175, as we saved £35 from before. We take that off £210, so our annual insurance was £175. So, finishing this question off, would you advise Kevin to change insurance companies? No, because pay if you pay early, you save £35 or £20 in comparison to the Lilliput insurance. Okay, question 5. Part A is, there's a massive hint, but if you look across how many marks there are, there's only 1 mark available in this question, so you don't have to do anything too taxing. It's not going to take you that long. So if you read the question, in Raytown, the mean monthly rainfall for 6 months was 28.5 millimetres. If it had rained 5 millimetres more each month, what would the mean monthly rainfall have been? So if it's 5 millimetres more each month, that means the average is just going to go up from 28.5. If you add on 5 to that, that will leave you with 33.5 millimetres. Okay, again, like I said before, massive hint. If you just look down in the bottom right corner there, 1 mark, that's a bit of a giveaway. You don't have to do that much calculations. Okay. In Tedbot, the rainfall to the nearest 5 millimetres for each of the 6 months was measured. The results are summarised in the table below. So, here, this is our frequency column here, 3, 2, 1. What I've done, I've multiplied across 30 and 3, 35 times 2 and 80 times 1. That will give me my column here, which we usually call our midpoint times frequency. But as these are not group intervals here, we're just using these values 30, 35 and 80. Okay. So it's asking me to find an estimate for the mean monthly rainfall for the 6 months. Okay. So what I've done, 30 times 3 plus 35 times 2 plus 80 times 1. So that's the sum of all my midpoints times my frequency over my total frequency. My total frequency is 6, which is this column here. 3 plus 2 plus 1, which will give me 6. So that gives me a nice rounded number on the top. 240 divided by 6, which will give me my answer of 40 millimetres. So that's my estimate for the mean. Part 2. It says, state the modal class and find an estimate for the median rainfall for the 6 months. So the modal class, modal means most common. So the most common class in here is the one with the biggest frequency, which is here. So our modal class would be 30. It then says estimate the median. So we are going to find halfway here between 3, 2 and 1. Our total frequency is 6. So we're looking for between the 3rd and 4th value. The 3rd and 4th value is between these two groups, between 30 and 35. So halfway between 30 and 35 is 32.5. So my modal class would be 30 and my median would be 32.5. Part 3. Which of the averages, mean, median or mode, would you choose to describe the rainfall for the 6 months? Give a reason for your choice. You could have either of the 3 with a valid reason. The mark scheme states if you say you would choose the mean, you must say that this is because you use all the data, every piece of information given in this table up here you use. The mode, as it shows the most common, so the most common in that table would be 30, as it appears 3 times, and median, as it's in the middle. So any one of those 3 with a valid reason would get you the mark. Okay, part B. The nth term of the sequence is n squared minus 6. Write down the first 3 terms of the sequence. This is simply putting in 1, 2 and 3 into this nth term. So 1 squared minus 6, which will give me minus 5. 2 squared minus 6, which will give me minus 2. And 3 squared minus 6, which will give me 3. Okay. Part B. Write down the nth term of the sequence 3, 11, 19, 27, 35. What I've done here, I've looked straight away at the difference between each one. As they are the same, we know this will be a linear sequence. So as they go up in 8s, that is what I'm going to put in front of my n. Okay, so I'm going to have 8n here. If I went up in my 8 times table, so 8, 16, 24, 32, so on, I want to find out how far away I am from these values. Okay, so from 3, 11, 19, and so on. The difference each time is minus 5. So my nth term of this sequence would be 8n minus 5. Right, part D. Input, add 4, multiply by 3, gives me my output. Question asks, write down the output when the input is n. What we're doing first of all here is adding 4. That is really important. We are adding 4, and after we are multiplying by 3. Okay, common misconception here is for people just to write n plus 4 times by 3. We know that we have to put in brackets at some stage just to show that we are using this first. We're adding 4 to n first before we multiply. So any one of these two answers would be correct. So question 6. One Monday morning, a bug fell down a hole 55 centimetres deep. The bug immediately tries to climb out of the hole. Okay. The bug climbs 1/4 of a metre during the day, but every night it slides down 1/8 of a metre. On what day will the bug get out of the hole? You must show you're working. Okay. Important information I'm going to get from this is 1/4 of a metre, which we know is 25 centimetres, and then 1/8 of a metre is 12.5 centimetres. It is half a quarter of a metre. Okay, so that is what I've done here. 1 metre is half of it's 50 centimetres, a quarter is 25, and we halve that again, gives me 1/8, which is 12.5 centimetres.
So where did you get 50 from?
So what I've done is a diagram, and you can definitely do this in your exam, just showing your step by step. Okay, we've got down here, we've got our bug. This hole is 55 centimetres deep. So if we start on a Monday, we climb up to 30 centimetres. Okay, we've climbed up 25 centimetres. But by the evening, it's gone down, or overnight, it's gone down another 12.5. So that's how we end up with 42.5 centimetres. In the next morning, on Tuesday, it rises another 25. So we've added 25 onto 42.5, which gives me 17.5. And then in the night, take away 12.5, so we're still 30 centimetres away. Repeat this again on Wednesday. We get to 5 centimetres, we're still not out, and overnight we go back down to 17.5. And on the Thursday morning, 17.5, we go up another 25 centimetres, and this is when the bug gets out of that hole.
We also need the points that are greater than 5 centimetres from A. So this blue line here was the very first line that I drew. Open your compass to around about 3 or 4 centimetres. You don't need to measure it, just something roughly about that. But whatever you do now, you must keep your compass at a consistent length. So your compass, the point would now be where that red dot is there, and you would draw this arc here like that. And then you'd move your compass to this point here, and you must keep your compass at exactly the same width that you just did, and you draw this arc here. Where they cross, I always go and like colour in where they intersect, and at point A, you get your ruler going through those 2 points and draw a straight line through there.
So
Okay.
blue line.
Yeah? Common misconception, people assume that the areas each side have to look exactly the same. They don't. It's just that this angle here needs to look the same size as this angle here. As long as like just this bit here looks grand, then you'll be fine. Okay? The next point said greater than 5 centimetres from A. So that was everything. I drew a 5 centimetre circle around the point A up until the edge of the circle. And I said, well, it's got to be everything past this line here. But because it said it needed the points nearer to AC, this was AC, so it was everything here that I've shaded. Okay? Just down the bottom of my paper there, the idea why I've done that is because the most common answer you're most likely to put if you've got it wrong is y to the power of 4. People get that by actually dividing the powers, but when you are dividing indices, you should be actually subtracting them, okay? So it should be y to the power of 6. For the next one, expanding, you've got this x by here. Hang on. You've got the x by here, and you've got this x cubed. Now this has got a power. This is x to the power of 1. So x to the power of 1 times x cubed goes straight to x to the power of 4. And then this x would also multiply by the plus 5. So you should get a final answer of x to the power of 4 plus 5x. Final one here. Before you start trying to solve this equation, you must expand that bracket. So expanding the bracket gives you 8x plus 17, so nothing changed on the left-hand side. Right-hand side goes to 3x plus 27. Collect your x's on one side, numbers on the other. So you see that we've taken the 3x over to become a minus 3x, the plus 17 to a minus 17. And then you get 5x equals 10, so x equals 2. Okay, so you see here, the most important thing is highlighted here is that this is a frequency polygon. Okay? You may also get asked to draw something called a grouped frequency diagram. But the frequency polygon is telling you two things to remember. You should remember that number one, it is a line graph. And number two, that you must plot it at the midpoints. Okay? Two very, very, very important things you need to remember about frequency polygons. If that said frequency diagram, it would be a bar chart where the bars touch. Okay, but whenever I do it, I go and highlight it and write down those 2 points straight away. So that's why MP's been written here, and they've been found here. So at 155 on the x-axis, you need to plot 2 at 165, 12, 175, 24, and so on. So your graph should look something like that by the time you're finished. Okay, they don't always do this, but they tend to peak in the middle and sort of come down again. Okay? Okay, and so, as I said, I wanted to show you this table so it was productive 4 minutes, because if you didn't get this table, then you weren't going to get the rest. So the key word there being cumulative. Cumulative means your running total. So where it says this is less than 150, if you look back at the previous page, it said 150 to 160. So there was no one who was less than 150 before. That's why that's 0. Then it says less than 160. So that's why you've got 2. But less than 170 being 14. Again, if you look at the previous page, there's a 2 and a 12. So the 2 and the 12 make 14. And then that 14 then, you're going to plus 24 on to get to 38. Then you plus your 36, and then you plus your 6 to get to 80. Okay? So your cumulative frequency graphs, frequency always goes on the y-axis, and it's going to be cumulative frequency this time. Your height then would go on the x-axis. If you're skipping values, ensure that you do something called a break in the axes, that little heartbeat monitor thing. And it's going to be like an S-shaped graph. Maybe not an S so much this time, but it always ends right up on what the top of the cumulative frequencies was. And then these lines here are drawn in for the next part. So median would be the middle. So I'd actually go and write on here M. You could actually go and say what value that is. Is that 181? Okay, you could have lower quartile, which is 173, and upper quartile, which is 186. And I'd actually go and physically write that on the lines. So I think it's a really nice sort of visual way of actually describing what's happening there. So the median 181, interquartile range 186, take away 173, which is 13. Okay. Okay then, so going over this question, the first one, 7 to the power of minus 2, you need to know a rule about what happens when you got to the minus powers. Most people say it's like minus 14 or minus 49. The minus just means 1 over. So I've gone and summarised it by here as that. So x to the minus a would equal 1 over x to the a. So whatever this power is here, it's still going to be that power there, but it's just without the minus there, and that minus means this, it means 1 over. Okay, so not a bad little note, especially if you've got different coloured pens. As soon as I saw that, for me, that's what did the job. That's how I got it stuck in my mind. So that'd be 1 over 7 squared. 7 squared being 49 is going to be 1 over 49. No need to change that to a decimal or anything like that. 13 to the power of 0, anything to the power of 0 is always 1. So even if it said there, one question I saw once said x, y, z to the power of 0. Anything is always 1. Okay. 15 squared, square root of 15 squared. Well, square rooting is like the opposite of squaring. So what these two do is they cancel each other out. So that cancels that out. So you're left just with 15. Next one here, standard form. Standard form has got to be a number between 1 but less than 10. So a number between 1 and 9.9 recurring, I suppose. So to make this number a number between 1 and 9, you put a decimal point here, bang in between the 3 and the 5, and to get this power of 7, you count how many numbers come after where you've just put your decimal point. So 1, 2, 3, 4, 5, 6, 7. So that's how we got the 7 there. If it's got noughts in front of it, the opposite way round is true. Okay? So you put your decimal point here, and you count back how many numbers to get back to that decimal point. So 1, 2, 3, 4, 5. But the key difference is that when it is a very small number, you put that to a minus power. Okay? So for small numbers, it just has a minus, same rule, but it has a minus in front of it, so 1.3. This one here, the best way I'd describe it is the numbers deal with the numbers, the tens deal with the tens. 4.8 divided by 1.2, it's just 4. 10 to the power of 16 divided by 10 to the power of 4, as we saw earlier with y's, you subtract those powers, so that's going to be 16, take away 4, gives me 12. So my full answer is going to be 4 times 10 to the power of 12. No need to take that out of standard form. Part E, which of the fractions, 1/8, 2/5, 2/3, and 7/20 is a recurring decimal, is 2/3. Hopefully you'd spot that from there. You should know 1/3 is 0.3 recurring, so 2/3 is 0.6 recurring. If you need to do any others, you could literally just set up like bus stop division if you wanted to. So you could do 8, then a bus stop and 1.00, and then start seeing how many times that 8 goes into 1, which is 0, into 10, which would be once, remainder 2, into 20 would be twice, remainder 4, and then add another 0 in here, and then into 40 would be 5. So you can find them all out by doing things like that by the side if you wanted to. And then finally, evaluate 2 and 2/3 times 2 and 3/4. These are what we call mixed numbers. You can't answer this in mixed numbers. You've got to turn them into top-heavy fractions. The way you do that is the big number, you times by the denominator, so you get 6, and then you add that numerator. So 2 times 3 is 6, add the 2 is 8, and then you put it all over what the original denominator was. So for instance, if I had 8 divided by 3, I could say that's 2 wholes and 2/3 remaining. Here, I do 2 times 4, which is 8, add the 3 is 11, and then put it over its original denominator. When you're multiplying fractions, 8 times 11, you just multiply the tops together to get 88, and you multiply the bottoms together to get 12. It did say in simplest form, so that means you must cancel down whenever possible. So from here, you might spot they're both even. So I could halve it to get 44 over 6. They're still both even, so 22 over 3. And what Sir's done is actually changed that back into a mixed number. It's fine to leave it as 22 over 3 or put it as 7 1/3. It's up to you.
Right, question 11. 3 geese and 2 ducks weigh 32 kilograms. 4 geese and 3 ducks weigh 44 kilograms. Geese weigh the same, ducks weigh the same. Automatically from this, I can see that I've got 2 unknowns. I've got geese and ducks, and I don't know what they weigh, but I know that when I have 3 geese and 2 ducks together, that's 32 kilograms. 4 geese and 3 ducks gives me 44. So, I can, from that, form a simultaneous equation. Okay, I'm going to come down to this for the final question at the end, but here I can form a simultaneous equation. I've got 3 geese and 2 ducks. We know that's equal to 32 kilograms. 4 geese and 3 ducks is equal to 44. When we have 2 unknowns, 2 unknown variables, so G and D in this case, we're going to have to solve simultaneously. So what I've done here, I want to get the coefficients of either the geese, so the G's, or the ducks to be the same. I've gone to get the ducks the same. So I've looked for the lowest common multiple of 2 and 3, which is 6. So I've times the whole top equation by 3. So that will give me my 6 ducks. And on the bottom one, I times the whole one by 2. So I'm going to call these 2 new equations 3 and 4. Okay? 9g plus 6d equals 96. The important thing here is to remember that you multiply the whole equation, not just the d's, the whole equation. So I've got 9g, 6d, and 96. Equation 4 will look like 8g plus 6d is equal to 88. Now what I want to do, as we've got the 6Ds both here, this is called the elimination method. So I'm going to take equation 3, I'm going to take away equation 4. Okay. If I do that, 9G take away 8G will leave me with G. 6D take away 6D, well, they cancel each other out. And then 96 minus 88 will give me 8. So my geese weigh 8 kilograms. Now I want to find out how much my ducks weigh. So if we use G is equal to 8, I'm going to sub that into equation 1. Okay, equation 1 which we formed earlier on, which is on the left hand side here. 3G plus 2D is equal to 32. Hence 3 times 8, because we know it, 8 is G now, plus 2D is equal to 32. That gives us 24 plus 2D is equal to 32. Get all the numbers on the right hand side and divide by 2. So we know the ducks are 4 kilograms each. Now going back to the question here, it says, what is the total weight of 2 geese and 1 duck? So we haven't quite finished the question here. 2 geese and 1 duck. So that basically means we're going to form an equation down here. 2 geese plus 1 duck, so 2 times 8 plus 1 times 4, which give me a total of 20 kilograms. 2 geese and 1 duck all added together gives me a total weight of 20 kilograms. Right, a sketch of y equals minus x squared minus 2x plus 24 is shown in the diagram below for values of x from 0 to 4. The following table gives values for x equals 0, 1, 2, 3 and 4. So if we look at our table, we have our x coordinates, our x values and their corresponding y values. The question asks us to use the values from the table and the trapezium rule with 4 strips to calculate an estimate for the area of the region bounded by the curve, the x-axis and the y-axis. Now you can split this shape up into 4 strips. Okay, so you have trapeziums that you form here, 1, 2, 3, and you'll have a triangle down here. However, I'm going to show you the method of using the trapezium rule here, which is, if I zoom in, area is the width here, the distance between the x values, which is 1, divided by 2, and I got my first height times by my first height plus 2 lots of the middle heights plus my last height. Okay, so all I need to do now is substitute in the values which are given to me in the table. So 1 is my width, 24 is my first height from my y value here, 21 is my value from here, my corresponding with my x value there, 16 is also a middle value, 9 is also a middle value, my last height here is 0. So some simple calculations, step by step. I've missed out a final step here, but if you add them all together you will get a total of 58. So that is the estimate for the area underneath that curve. Okay, this question says there are 2 similar triangular prisms, sorry. The areas of the ends of the smaller and larger prisms are 16 centimeters squared and 25 centimeters squared. So that's why we just placed in here 16 centimeters squared at the end there and 25 centimeters squared there. Given that the length of the larger prism is 7.5 centimeters, so that's this length here, 7.5 centimeters, find the length of the smaller prism. So what we're dealing with here, we've got the area here. So what I'm going to find first of all is the area scale factor. How many times bigger is this than this? Okay, so the area scale factor, my smaller one is on the top, so how do I get from the biggest here, the biggest shape to the smallest? That would be 16 over 25. That's the area scale factor. To get to the length scale factor, we must square root that. Okay, if we square root 16, that gives us 4. If we square root 25, that gives me 5. So my length scale factor is 4/5. This here, this length here is 4/5 the size of this one. So we need to find 4/5 of 7.5 centimetres. If you find 1/5 of 7.5, that will give me 1.5 centimetres, but I want 4 of those, which is 6 centimetres. So my length of my smaller triangular prism is 6 centimetres. Circle theorems, question 14. So, this question says, find the size of each of the following angles. You must give reasons for your answer. If you don't provide reasons, you will lose marks. Okay? On my answer here, I have drawn in all the angles that I can find out straight away. So I know that here I have 130 degrees. From that, I can see that there is a quadrilateral here. So a four-sided shape, each corner touching the edge of the circle, so the circumference of the circle. This is called a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles add up to 180 degrees. So here, my angle DCB is 50 degrees, because 130 add 50 degrees is 180. So that's what I've labelled there. Here is actually asking me to find the obtuse DOB, the angle which is obtuse DOB. So this is this angle here. How I've got it to be 100 degrees is because angles at the centre are twice the angle at the circumference. So I've doubled my angle here to give myself 100 degrees. So my answer would be looking like this. 100 degrees, first of all, because angles in a cyclic quadrilateral, which give me my 50-degree angle. Then my angle at the centre is twice the angle at the circumference. Okay. Part B is asking me to find angle BDC. That is this angle here, BDC. It is always the angle with a letter in the middle, so BDC. So, on here, if you look down here, I've got a straight line. I've already got 52 degrees, 50 degrees from my previous answer, and I want to find out what my remaining angle is. All I've done here is done 52, add 50, and I've taken that away from 180 degrees, which leaves me with 78 degrees. This angle here is the same as this angle here due to alternate segment theorem. So part B is 78 degrees. Why? Because of alternate segment theorem. Given that y is inversely proportional to x, okay, and that y is equal to 5 when x is equal to 2, find an expression for y in terms of x. Okay. So the most common misconception here is y is inversely proportional to x, not x squared. So what I'm going to form here is an equation looking like this. Y with my alpha sign is proportional to 1 over x. Inversely proportional, that's when it becomes a fraction, 1 over x. So now I'm going to write that as y is equal to k over x. K is a constant that I want to find out. I find that out by substituting my values in from here. Y is equal to 5 and x equals to 2. So I sub that into this equation here. That will leave me with 5 is equal to k divided by 2. To get that k on its own, what I'm going to do, I'm going to bring that 2 up, so I'm going to times by 2, so I'm going to be left with k is equal to 10. That will not give me my full 3 marks. My full 3 marks will come from when I write that y is in terms of x. Okay, so find an expression for y in terms of x. So that basically means instead of the k, I'm going to have 10. So y is equal to 10 over x. Okay, part B. Complete the following table for values of x and y. This is basically substituting in your values for y and x into your equation which you worked out in part A. So, when x is equal to minus 4, what I've done here is, I don't know why, I'm going to put in minus 4 into here, so I've got 10 divided by minus 4, which is 2.5. This is a slightly harder one when I want to find x. So I know y is 0.2 is equal to 10 divided by x. What I'm going to do is I'm going to make x the subject of that equation, okay? So I'm going to bring x up and I'm going to swap it for 0.2. So I'm going to ask myself, how many 0.2s are there in 10? What you could do is how many 0.2s are in a whole one? That's 5. So how many are in a 10 is going to be 50. So my two answers, minus 2.5 and 50. Right, the graph of the equation y equals x cubed plus 9x squared plus 11x minus 21 is shown on the graph below. Use the graph above to answer the following questions. Solve. Solve means find values for x. So that basically means where does this curve cross the x-axis. So these three circles here in red are the 3 points where they cross the x-axis. So those are my three solutions. At x equals minus 7, x equals minus 3, and x equals 1. Part B, it says by drawing a suitable straight line, solve the equation. The only thing difference between these two equations, this one up here and this one here, is this extra bit here which I've circled, 60 minus 30x. Okay, so my equation, I'm going to draw this straight line, y equals 60 minus 30x. This can be done fairly easily by thinking of your version of a straight line, y equals mx plus c. So whatever's in front of the x will be our gradient, so our gradient is going to be minus 30, and what c is where it crosses the x-axis. So it crosses the x-axis at 60. So that's what I've drawn on my graph here. 60 crosses the y-axis, with a negative gradient 30. So for every one square it goes across, it goes 30 down. Every one square it goes right, it goes 30 down. My questions ask me to solve this, so I want to find out where or what my x value is. That is what I've circled here. I've circled the points where the line and the curve intersect. That for me on my graph was x equals 1.4 to 1.5. So where it crosses they intersect, so there's 1.4 to 1.5.
So usually we see stuff like with the graphs of sine and cos coming up on the calculator paper. They ask you to work stuff out from it. In this case, they've told you that sine x is equal to minus 0.8. Now that's a very, very similar idea of what we were just doing a moment ago, where you're going to draw the graph of the second bit here. So if I circle that bit there, we want to draw y equals minus 0.8. So what we do on the y-axis, we actually go and find the value of 0.8 or minus 0.8, which is here. You draw a straight line going across and seeing where it intersects the curve, and you should be expecting it to hit the curve at least two places in the range of 0 to 360. First place, coming up, reading off your value there, we've got it approximately 233, but we're doing this off the iPad, so yours will be more accurate than ours. And then the other value here, and again reading that off, we've got 307. Okay, so you go and draw that line at minus 0.8, lovely straight line. Make sure you work out your scale there properly. 0.5 divided by 10 tells you going up. Each little square is worth 0.05. So that's why this square is here for minus 0.8.
Question 18, part A. It says the diagram shows a sketch of y equals f of x. On the same diagram, sketch the curve y equals f of x plus 3. Mark clearly the value of x at the point where this curve crosses the x-axis. So, what we're looking at here is this bit, x plus 3. When it's inside the brackets, that's when we move left and right. So we move in the x-axis left and right. As it's a plus 3, we shift 3 places to the left. okay? 3 places to the left. The most important point in this answer is your point that you plot here. You're showing, or you're making sure you know what the value of x is. It's minus 5 as it's been shifted 3 places to the left. As it's minus 2 before, take away another 3, gives you minus 5. Part B says the diagram shows a sketch of y equals gx, g of x. So on the same diagram, sketch the curve y equals minus g of x. Minus g of x, okay, is a reflection in the x-axis. Imagine you had the curve y equals x squared. That's a happy face. Y equals minus x squared is a sad face when it's flipped. Okay, it's upside down. So again, the most important point here is you plotting on the y-axis where it crosses. So at this point, it's minus 6. Right, express the following as a single fraction in its simplest form. Okay, no solving here, just leave it in a single fraction in its simplest form. So we have two algebraic equations here. We've got 8 over 3 minus x minus 2 over x minus 5. Now I'm going to do a thing called cross multiplication. So I'm going to look here, I'm going to times everything, all my fraction here by x minus 5, and all my fraction here by 3 minus x. When you think of it as a simple adding simple fractions, so you have 1/2 add 1/3, you want to get the denominators the same. Okay, getting the denominators the same, you're going to have to find the lowest common multiple. So we did some cross multiplication. Okay, so what I'm going to do here is times the whole left fraction by x minus 5, which I've highlighted in blue there. The aim of this is to get the denominators the same. So here I've got 3 minus x times x minus 5, and the right fraction then I'm going to times everything by 3 minus x, which again will leave me with the same denominator. Once they have the same denominators, then we can put it all as one fraction. So I've done 2 steps from here to here. I've done 8x minus 40, so I've expanded out of the brackets. Then I've done minus 6 plus 2x. Be really, really careful here. We've got a minus outside between the 2 fractions. That is going to take part here. So we've got 2 times 3, which is 6. But as it's a minus outside, that's where we get the minus 6 here. 2 times minus x is minus 2x. But as we've got a minus here, 2 minuses make a plus. So that's going to leave us with plus 2x. Now all we need to do is collect the like terms. So we've got 8x and we've got 2x, which will give us 10x. And we've got minus 40 minus 6, which gives us minus 46. So our fraction in its simplest form is 10x minus 46 over 3 minus x times x minus 5. Okay, part B. Hence, that means we're going to use our answer or solution to part A to solve the following equation. So we're going to use this up here to answer this question. So we know that this up here is equal to 0. So 10 over x, 10x minus 46 over 3 minus x minus 5 is equal to 0. I don't like this denominator. I'm going to get rid of that denominator. I'm going to multiply it by both sides by 3 minus x minus 5. But if I multiply that by 0, that's just going to leave me with 0. So I'm just left with the linear equation of 10x minus 46 is equal to 0. Now with some simple steps in solving linear equation, add 46 to both sides, then divide by 10, you will be left with 46 over 10 or 4.6.